The second video, so we have already talked about this PPRL. So the liquid column is this equation AP minus AR. AR is the rod area, AP is the inside diameter of the pump, the diameter of the pipe, producing pipe. Okay, this is the equation. And then weight of the rod is the weight of the rod itself, and load of the acceleration, remember that this is the maximum, so lambda 1 weight of the rod, and this is due to PWF or P3 AP. Okay, and if we rearrange everything, we have this equation. Rearrange this one, and then weight of the fluid, we call it weight of the fluid, is this one, and the buoyant due to rod is this one. So we say that weight of the fluid minus the buoyant plus weight of the rod, acceleration, and due to PWF. And if we see that the buoyant force due to the rod steel is this equation, from here become this equation, and the density of this we divided by the density of the steel. So the density of the steel is 490 pound force per feet cube. So if we call it, this is weight of the rod itself. Okay, so this is the rest of it is the buoyant. So the buoyant is become this equation. Okay, so this is the force of buoyant force, and this is the weight of the rod. So remember that weight of the rod is this equation, so it becomes this equation. So the buoyant effect is the negative force, because the force is going to the bottom and going to up is become negative. Okay, so for the maximum of PPRL, the buoyant is small. Remember that, because the buoyant is the effect, it's almost the same effect with the PWF. The direction is opposite of the weight. Okay, so from the buoyant effect, we use the lightest one, because it's forced to the upward. So we want to see the maximum of the weight. So we use the lightest oil. The lightest oil is 50 degree API. Okay, because everything goes down, buoyant is going up, so we choose the lightest oil. So in order to have the very heavy force going to the bottom, so this is from this one become this equation. So equation 16 become this long equation, or PPRL, if you zero range everything, become this equation. Okay, MPRL is going to the bottom, which is minimum. Okay, load as plunger and friction is ignored. So we have a load of the rod, load of the acceleration minus the buoyancy. Okay, this is the minimum, and then it become this equation. Remember that from the above equation here, from everything we written up there. So MPRL become this simple equation. So and this one, it moves up, so the weight of the rod become negative, weight of the rod positive. I'm sorry, this is goes down also. This is goes down also. Okay. So from this equation there, so load acceleration is negative, friction buoyant is negative. Okay. So become this equation. And from the equation number 7, we have this equation. As we combine, so if we plug in the ampere L here, so we end up with having the equation, or the minimum stress is this equation. Okay, so we have the alpha 2, so we plug in the alpha 2 here. So remember, this is the minimum. Okay, and we combine with the example equation number 9. What is equation 9? Remember PPRL, the long one here, so we combine it. We combine it, so we end up with having this long equation, or finally become equation 31. And then if we rearrange equation number 23 for P3 or PWF, we end up with having this equation, and we plug in everything PPRL in here. We finally have this long equation. So if we see equation number 36, so what is it actually? If you want to have a certain rate, because rate is will derive the SNN, okay. So if you have a certain P, so P3, so, and what we have to what you fulfill this long equation. Okay, so this long equation actually it has to be fulfilled in order to have a certain rate and a certain P3. Okay, and we divide it by 2, so we see one side only, this side. So if we have a plus, we have a minus, so we part of it, this one. So and then we end up with having this long equation. Okay, and after we derive everything, we end up with having number 41. So C and P first for the plus and minus, or minus and plus. So the first one, if you have only plus, has to be for conventional. Second one for Mark II, and this one minus for conventional, plus for Mark II. So the first one is the conventional. Okay, if you say this one plus minus, conventional plus, and then Mark II is negative. So this equation actually is the requirement for P1 of certain Sn with different configuration. So means that if we have a certain configuration of a well and we have a PWF, we end up with having a certain rate. Okay, this is what we are looking for, the rate. Okay, so now we combine between the stroke and everything with the what you call it, with the pump intake curve. Okay, the curve. So this is the curve. We want to make a pump intake curve. Okay. Uh, what is pump intake curve? Pump intake curve is something like, wow, this one has to be 100%. Much easier for me to see. Pump intake pulse, something like this. This is pump intake curve. This is IPR curve. This is pump intake curve. Okay. So if we have Sn square in here, and then we replace it with this equation, so we end up with having, let's see, okay, this equation 41 and 43, we end up with having this equation. Okay. So if we see the V is going up here, so this is equation for this one is an A, this one is a B. So what we have is, if we have a certain N stroke per minute, okay, this is stroke per minute, so we will have this equation for a certain stroke per minute, because everything is given. You have your equipment, you have your tool, you have your pump and everything, and you have you set up the end. So this is what we expected for the pump intake curve. So the curve to go up. So PWF equal A plus PQ. Okay. We will continue with the third video.